Welcome to today's lesson in physics. We already discussed the physical quantity work and we obtained the expression for work as force into displacement or F dot S. Now let's see what do we mean by the constant force and variable force. Actually, we can use graphs to find work done. And we can use the graphs to calculate the work done by constant force and variable force. And the graphs are the force versus displacement graph. That means the force will be taken along y-axis and displacement will be taken along x-axis. So let's see what is meant by constant force. Constant force means a force which remains constant throughout the displacement of the object. That's what we mean by constant force. That means the force remains constant in both magnitude and direction. As you can see the graph, so this graph shows a constant force. So from the displacement x1 to x2, the force has the same value. That means force is constant in both magnitude and direction. Such a force is constant force. So this is the force displacement graph of a constant force. And you know the expression for the work done is force into displacement, and we can see that force into displacement, that is the same as area under the graph. That means area of the space between the graph and x-axis, that area gives the displacement. So that is a general fact, that is area under force displacement graph gives work done. So to find work done, if you know the graph, it's enough to find the area under force displacement graph. And this is what this yellow shaded region in that diagram shows, and that is the work done by a constant force. Similarly, when we come to a graph like this, so here this also a force displacement graph. The only difference is this: here the force is not having a constant magnitude. The force is not having a constant magnitude, and that force we say it is a variable force. So to find the work done by the variable force, we can find the area under that graph. So here the shape of the that a shaded region, it is a triangle, and you can use the relation half BH. And the next graph, so this is not a constantly changing, this is a constantly changing graph, but the change is a linear change. This also is a constantly changing force, but it is not a straight line. Okay, randomly variable force it is actually. So to find the work done, again you can find the area. So in this case and all, finding the area under the graph is not an easy task. Okay, so again, whatever be the shape of the graph, the force or the work done by the variable force or any force can be found by finding the area under the force displacement graph, and this is a variable force. Hope you understood the difference between the constant force and variable force. In the case of a variable force, the force changes its magnitude continuously. That means in a continuous manner the magnitude of force is changing. Such a force we call as variable force. Now we will discuss how to find work done by a variable force. So as we stated, it's enough to find area. So how can that be done? So the thing is this: to find that area or to find that work done, we will divide that interval from xi to xf. So xi and xf, they are the initial and final positions of the object. So the object is moved from xi to xf. During that displacement, actually the force is not constant. Now that interval from xi to xf, actually it is divided into small displacements of delta x, as you can see in the diagram. It is divided into small displacements delta x, such that in that delta x, during one small delta x, that force F can be taken to be constant. In that way, we are dividing that interval from xi to xf into small displacements of delta x each, and during that delta x displacement, the force can be assumed to be constant. And for each delta x, you can find the work done, because during that displacement delta x, the force is constant. So force into displacement will give you work done. So to find the total work done, you can add all these small works. That means for each interval delta x, you can find the work done and finally add, which will give you the total work done for the displacement from xi to xf. This is the logic involved in finding work done by a variable force. So that finding work done can be done in two ways. That is the case. That means, so as I said, we have all the what rectangular areas, we have the total work done as summation xi to xf f of x delta x. Okay, so when you add all the individual works, you will get the total work. And actually, that continuous addition is the process of integration. So actually, this is the actual or the real equation for work done by a variable force. Work done by a variable force is integral xi to xf fx dx. Integral xi to fx dx. That means xi and xf, they are the initial and final positions, and you have to integrate that fx. Okay, so this is the expression for work done by the variable force. Now here we have a problem from the textbook, example problem from the textbook. A woman pushes a trunk on a railway platform, which is a rough surface. She applies a force of 100 Newton over a distance of 10 meter. Thereafter, she gets tired and her applied force reduces linearly with distance to 50 Newton. The total distance by which the trunk has been moved is 20 meter. Plot a force applied by the woman and the frictional force, which is 50 Newton, and calculate the work done by the two forces over 20 meter. So from the question, it's given that the total distance moved by the trunk is 20 meter, and the woman pushes the trunk with a constant force till 10 meter. So up to 10 meter distance, the force applied by the woman is 100 Newton, which is a constant one. And thereafter, from 10 meter to 20 meter, the force is a variable force and it reduces to 50 Newton linearly. That means from 10 meter distance to 20 meter distance, when she pushes the trunk, her force is decreasing from that 100 Newton to 50 Newton linearly. Okay, so in that way we have to plot the graph. So when we plot the graph, we will get the graph like this. So along x-axis, as we said earlier, we have the displacement. Along y-axis, we have the force. So up to 10 meter, as you can see, the force is constant. Okay, 100 Newton. From 10 meter to 20 meter, the force is decreasing from 100 to 50. Okay, so that is what the graph shows. Now you are asked to find, and you are asked to show frictional force also. Frictional force is something which is opposing the actual motion. So it should be shown in the fourth quadrant. That means on the lower part of the graph. That is why it is drawn like that, because force is opposite to displacement. Okay, so we have the constant frictional force, that is 15 Newton. So that's what this line shows, that is the work done by the frictional force. Now we are asked to find the work done by the applied force and work done by the frictional force over the distance 20 meter. Let's first discuss work done by the applied force. So when we discussed that force displacement graph, we already said area under the graph gives the work done. So to find the work done, here it is easy to find that area. So when we find the work done by the applied force, here you can find that area in two different parts. That means first you have a rectangle, then you have a trapezium, then adding you will have the total work done. Okay, so first area of rectangle, it is AB into AD, and area of trapezium is half into CD plus EI into DI, and hence the values are, so this is 100 into 10, that is 1000, and here for trapezium it is half into, we can see that the parallel sides are what 10 100 plus 50 plus 100 plus 50 into that perpendicular distance between those parallel sides, it is 20 minus 10, that is 10. So 10 by 2 it is 5, 5 into 150, 5 into 150, it is 750. So work done from 10 meter to 20 meter, it is 750. So 1750 is the total work done. 1750 joule is the total work done. You can follow the steps. Okay. Now work done by the frictional force is very easy because it's a constant force. So minus 50 into 20, that is minus 1000 joule. So that is the work done by the frictional force. Okay.